Hi, in this video we'll cover an example of an infrastructure project. It's part of the eToolLCD infrastructure training. And we have here a basic SketchUp model of a railroad overpass, including sections of the road, structural elements for the bridge, the rail itself. We're not modeling the train, just representing here the scope that we're capturing, including all structural elements, foundations and superstructure elements, beams, and all the components you can see here, including concrete elements, steel, the rail elements as well, the track, ballast. So the first thing we need to do is create our project in eToolLCD. And in this case, I'm using an existing project, which is part of the eToolLCD example project in the software as you create a new account. So this will be available for you, for every new user. So this project has been created using the default LCI group. So something that you can select at project level. We have the impact dataset as well. This one has been using the default. You define the version and the region of your LCI source, as well as other parameters here, project details level. All lifecycle modules are included, so we're capturing the full project lifecycle impacts here, focusing on carbon for this example. We have a list of all the main indicators as required by the standards. So it's not just a carbon assessment, although we're focusing on carbon impacts. You also have all the other indicators available for this data set. You can also regionalize your project depending on the electricity grids and also the default gas and water supply and treatment grids. So this is just to set the site attributes for your projects. We're using an example here in Tasmania, because they have lower intensity grid, therefore the imported impacts or the initial and the construction impacts are more representative. So the operational impacts are not so dominant. And you can also set here financial parameters in the quality checks project level. So we start by creating a new structure. We'll call it the railroad overpass, and it is infrastructure, civil structure. I'll just give a generic example here for now. And here is our railroad example project. We have all the details required. But in this case, I'm just going to include the basics here. Then you select your construction scope. You note that the terminology used here for the categories is based on a building standard. So this is following the RICS guidance and the terminology for buildings. It's a little bit clunky for infrastructure, but we can still get the closest possible categories for our components and make sure we're categorizing the impacts correctly. So this is set at construction scope level. And we also have the impacts associated with energy and water. In this case, I'm just going to put in some lighting as an example. So I'm going to get rid of these and I'm just going to add lighting as one of my water lighting impacts. Okay, so we're set for the structure. The next step is to create a design. So creating a new design, the parameters here again, they are focused on buildings. Therefore, go through quickly just to get the model set up. The purpose of the LCA is a baseline. And these parameters here, they use for calculating lifespan. and more tailored for buildings. As I said, we're just going to use standard parameters here to get the model created. We use a rail bridge to begin with, but we'll also add another function to represent the rail itself. Okay, so now we have our design. As I said, there's only one function to begin with. I'm going to create another function here. So we can segment the templates or segment the components of our projects into specific functions. This is useful when you have larger projects or you want to segment the impacts in rail stations and tunnels and rail itself for the civils infrastructure. So we just use a light railway example here. Railway, there's no asset ID or anything, it's just optional. And then this is also applicable to buildings, so just use it's usable. Now we have two functions, and I'll show you the details this stage. We are assuming, although the structural life limit is 100 years, we're assuming 25 years lifespan for this example. Just to begin with, we'll change this later to show you what this impact the overall results. Okay, so now back to our model here. What I've done is I extracted the bill of quantities, so materials specification and quantities into an Excel file. So this information here was captured via SketchUp, going through the entities and the volume of all the different components. And you can see they're all in cubic meters. So one thing I've done here to facilitate the import and the matching of the templates is to understand the associated template in the eToolLCD library. So this process involves finding the right template that is applicable to your construction component, and also ensure the template has the same unit, the same reference, so it's applicable across. You can see, for example, in this first asphalt on elevated slab, the information I got out of the model is in cubic meters, but the template that I'm using is in floor area, square meters. So there's a unit conversion here where I have to divide the total volume by the thickness of the asphalt layer, or the other way around. If you have the area, then you can calculate the thickness and adjust your template. So this is the fundamental knowledge in the software, is to understand how the templates are created and the unit that is used as a basis for that template. So another example here is the asphalt on ground. And in this case, I have the asphalt on ground here, and I also have the road aggregate, the base course down here, and this one, I merged them together into a single template. So I'm not adding one template separately for the base course, it's included on this one here. So the external works, the asphalt plus the aggregate base. Again, this is in floor area, so I converted from the cubic meters. Same with balustrade, although this is a smaller impact overall. This one is in linear meters in the software. This one was actually created in 3 linear meters each balustrade. So you have to divide your total linear meters by 3 to make sure you're entering the correct information, material quantity. So this customization of templates and understanding the correct unit is fundamental to get the right quantities into your model, and also adjusting the information. You can capture this information from 3D models or SketchUp models or cost plans. Sometimes they'll have different units from the units in the templates. So just double check that, as this is really, really important for the streamlining the process, making sure you are capturing the right amount of materials and the right scope. A few more details here is that some templates, they have steel reinforcement aggregated in a material. So for the elevated slab here, for example, I've got the volume, and the right template is the concrete as well as 3.8% reinforcement steel. So I have a template ready for that combines both concrete and steel. I also created a different process just to show an example where I have the concrete in one template and the reinforcement bar on a different template. So this is for the pile cap, where I have just the volume of concrete, poured concrete, and then the steel separately. So you can change that, you can customize the way you want, the best suit you, the type of information you have, data entry, to match with the eTool template system to help you import the information. So after I've understood more details how I'm going to match, I created a file that will help me transferring the information via CSV. So I have here just a basic Google sheet where I have a list of the elements, and I have the total quantity and the unit of measurement. And from this, I will create an Excel or CSV file separated by comma. And it's now saved in the desktop here. I'll go back to the software, go to my design. You see the design is empty. There's no information, no templates. We can add the templates one by one. Here, the template here, and choosing from the library. I'll show you the import option via CSV in this example, but in other training models, you can have more better understanding of the other options, either by entering manually each template or integrating with a 3D model or Revit model. So I choose the import template, and it brings me the import file here, import page. I will select my CSV file. Okay, now I'm importing all this into the main function, rail bridge, to begin with, but I can customize later, changing to different functions. And I'll tell the software what each column here represents. So this first one is the template name. This is the quantity. This one, the unit. And now we have to do the matching for all of the templates. So the software has an algorithm that recognizes the template. So you have the similar terminology here. It automatically recognizes the template. As you can see, because I was practicing this example, the templates have been loaded automatically. Just going to double check they're all fine. They're matching my specification. Yes, concrete floor, board pile. So I can double check with my spreadsheet that I had initially. So if this is a very long list, you can skip this and customize later or ignore some of the items. In this case, we have to go through one by one just to make sure it's all correct. Yes, so the reinforcement bar, as I said, is a separate template. Precast elements have been matched properly as well with the integrated steel reinforcement. So it's the same template here. Now it's for the frame, beams and columns elements properly matched. We included different templates here, like line marking for the highway. Just trying to capture as much as possible in this example. Some templates are very detailed, and you notice that. Others are a little bit more basic. So at early stage analysis, you can, or if it's a more detailed analysis, you can deep dive on the customization of your templates. So we have here the ballasted track, the rail aggregate ballast, and also fastening, the tie plate and the spikes, the track itself, the timber sleepers, which this one is on a unit measurement, so 190 sleepers. And I also added here 10 street lights just to capture some operational energy impacts. So I'm happy with the matching. Here I can also select the function. So in this case, this is the rail bridge, the railway, is the sleepers, the track, and also these other ones here for the railway. All others are part of the bridge itself. So we'll segment the template into different functions as well. And I will save this as a file for my docs. I'll just call this the material takeoff. Okay, using this as a just to keep a record of the documentation used. And we'll save this to our docs. Okay, perfect. So now we have a list of all the templates that were imported. You can see the total impacts, in this case dominated by products, construction impacts as well, followed by energy. So this will change if we increase the design life to 100 years, for example, where we see the initial impacts diluted, and then the operational impacts, they start to become more relevant. So you can play with the design life as well to understand the relevance of the impacts. Now maintenance and energy impacts are more relevant. Just thought I'll make it simple to begin with a shorter lifespan, so we're capturing the initial impacts with a little bit more emphasis. So I'll go back to 25 years. Now you have a baseline model with all your initial impacts, and also a list of your templates that were imported here from the CSV file. Okay, so from this you can start looking at the hotspot via the analysis or the top impacts report, for example, and then clone your model, start planning your design improvements. So those topics will be covered in more details in different terrain models.